Okay, in this video we're going to continue talking about conic sections, and we're going to look at what are called hyperbolas. So the difference between a hyperbola and an ellipse is simply that instead of finding the sum of the distances to these foci, we're finding the difference of those. And so our equations are going to look very similar to that of an ellipse, but instead you're going to have subtraction here. So x squared over a squared minus y squared over b squared equals 1. Now, a little other caveat here and how it's a little bit different than an ellipse is that a does not necessarily have to be greater than b. They just both have to be positive numbers. So what's going to determine the orientation of the ellipse is not which number on bottom is bigger. It's going to be which one of my x or y is my positive value. So if we have x squared minus y squared, the orientation here is going to be horizontal. But if we have y squared minus x squared, then our orientation switches and becomes vertical. Okay. Whichever one is the positive one, that determines the vertices. So again, the vertices are going to be kind of the endpoints there of your hyperbola. If it is horizontal in orientation, we list those as x coordinates. If it's vertical, those are y coordinates. Then we're also going to have some asymptotes when we graph these. And those are determined by either plus or minus b over a or a over b. Now when we actually get into the graphing of this, I'm going to show you how you can very easily determine the equation of the asymptotes by making your graph first. But just notice that it's going to be, it's going to be the y change over the x change, and that's going to give us our slope of our lines, right? So in this case, b is under y and a is under x, and so it's b over a. But in this case, a is under y, and again, my y change is going to be first. It's on top. It's a over b instead of b over a. Okay. But again, we'll look at that when we look at the graph and be able to find those a little bit easier. The foci formula, again, similar to that of an ellipse. Instead, it's plus over here instead of minus. So c squared is a squared plus b squared. So what you're going to do here is just simply add the two numbers that you see on the bottom of your equation and take the square root, and that's going to give you the value of c. And then again, it's going to the foci are going to be inside the hyperbolas, so they need to happen on the same axis of what kind of orientation you have. So if it is horizontal in orientation, your foci are on the x-axis, and then vice versa. If it's vertical, they're on the y-axis. But again, the finding of that c value should be a pretty easy task to do. So let's go ahead and jump into an example here. So what I'm going to do first is something that's not actually part of the graph. I'm going to, once I get my equation in the form that I want it to be in, I'm going to sketch what's called a central box. Now this is not actually part of the graph, but it's going to help me get a very defined shape for my hyperbola and for my asymptotes. Okay, so we're going to sketch what's called a central box. Then we're going to sketch the asymptotes, plot the vertices, and then sketch the hyperbola. Okay, so it's going to be the same thing every time in terms of getting that central box and then the asymptotes and doing it in that order. And it's going to really help you get your shape of your hyperbola. So hyperbola has the equation 9x squared minus 16y squared equals 144. Now again, we want this to be equal to 1 on this side, so I'm going to divide all of these by 144. That's my first task. 9 over 144, again, that's going to simplify to 1/16. So I'm going to get x squared over 16 minus y squared over 9, and that will equal 1. So again, if I divide all of this by 144, I get to this equation. Now I know that it's going to be, at that point, I know it's going to be horizontal in orientation because my x term is my positive one. It has nothing to do with the fact that 16 is bigger than 9. Okay, so with an ellipse, that's what you look at, but with a hyperbola, it's which one is positive, and in this case, that's the x squared, so it's going to be horizontal. I'm actually, at that point, going to go ahead and plot some points here to get my central box. So the number underneath x is 16, so that tells me I'm going to go out 4 in each direction on the x-axis. And then the number underneath y is 9, so I'm going to go 3 in each direction on the y-axis. And once I do that, just like graphing an ellipse, I'm going to graph what's called a central box here. So I'm going to make a box that goes through all of those points. And I kind of missed that one at the top, but that's what you're going to do first. Okay, so it's stretched 4 horizontally and 3 vertically. After doing that, I'm actually going to go ahead and graph my asymptotes, and the asymptotes now are simply just going to go through the corners of the box. So if you think about that, I just need to have an asymptote that goes through this corner, through the origin, and up through this corner. Okay, so if you want to try to kind of calculate that slope to make that happen, you can just go down, keep going down 3 and over 4, and you can figure that out. But what I'm going to do is I'm going to graph the asymptotes there that go through the corners of the box and through the origin. So it's going to look something like that. And then this way, something like, well, let me try that one again. It's a little bit off here. Something like that. Okay, and there are my asymptotes. So by drawing that central box, I can really get those lines to go the way that I need them to go. And then we'll write the equations for those in just a minute, but I'm going to go ahead and graph. Again, kind of like an ellipse, once you get to that point, the actual sketching of the graph is probably the easy part. So since I know that this is horizontal in orientation because x squared is first, that means that my vertices are these points at the end of the box on the horizontal stretch. Okay? If the y squared would be first, I'd do everything the exact same way I've just done this, except my vertices are going to be the points at the top and the bottom of this box. So because I know those are my vertices, I can actually go ahead and sketch my hyperbola from that. Okay, obviously you're just approaching those asymptotes. Now, if you actually graphed this equation, all you would see are those black graphs that I have graphed there. You're not going to see the central box. You're not going to see the asymptotes unless you graph those yourself. So the actual hyperbola is just those 2 black graphs. It's just that all of that other information helps us to get a more accurate graph for that. Okay, so after doing that graph, I'm going to go through and then find those pieces of information. So the vertices, again, because x came first, I know it's the number under x. It's going to be plus and minus 4, comma 0. The foci, we're going to use our c squared equals a squared plus b squared in this case formula. So all you're doing here is you're simply just going to take the numbers on bottom, add them together. So 16 plus 9 is 25, and then take the square root. And that would give us that c is plus and minus 5, which means our foci have coordinates of plus or minus 5, comma 0. So I'm going to go ahead and plot those as well. Those should always occur inside of your hyperbola, so they should be going around those things. So that happened, that's good. If you get values that don't make that happen, then you use the formula incorrectly. And then we want to find the asymptotes. Now, I told you I would have a better way to find the asymptotes, and it's simply this. If I think about going through the origin and then going through the top corner of the box, if you can just count that rise over run, that's your slope, right? So we went up 3 and over 4, which means our slope is 3/4, and then just x. My y-intercept is 0 because it goes through the origin. So what's the slope of the other line? Well, it's the same thing except negative, right? It's down 3 and over 4. So your asymptotes are going to be y equals plus and minus whatever that rise over run is to get through the corner of that box from the origin, plus or minus 3/4x. And I didn't really have to worry about, well, what's a and what's b down here. I'm just sticking with, if I can graph it first, then I can look at the graph and figure out what that stretch would be vertically and horizontally to get the equation of those asymptotes. Okay, so vertices, foci, asymptotes. Again, all pretty easy to find if you go ahead and actually make the graph first. Second equation here, we have the vertices, we have the foci, we want to sketch the graph. So I'm going to write the equation and then also sketch the graph here. Now, my vertices in this case are y coordinates. So that tells me that with my equation, it's going to be y squared minus x squared. And I also know that since my vertices are plus and minus 3, that this is going to be 9. Okay. Now, the x squared, the number underneath here, could be a bigger number. Okay. But I know that because this is 3, and it's a y coordinate, that my stretch is vertical, and the number underneath y would be 9. So the foci are plus and minus 4, or say 0, plus or minus 4. So if I think about that equation, we've got c squared equals a squared plus b squared. Because my foci is plus or minus 4, I know that c is 4, so I'm going to get 16 there, equals, I've got a squared plus b squared, right? So it doesn't really matter which one is a or b, because I know that one of them is 9. And so what does b squared have to be? It has to be 7 here. Okay, I'm adding two things together, and I'm supposed to get 16. So that means that this needs to be 7. Okay, again, that number could have worked out to be a bigger number than 9. Totally fine. I just know that I had 9 underneath y squared because of the y coordinate here. So my equation, y squared over 9 minus x squared over 7 equals 1. I'm going to go ahead and graph this. So the central box for the y direction, I need to go out 3. So that's going to be here and here. My x direction, we're going to go out the square root of 7. So the square root of 7 is going to be a number that's between 2 and 3. So I'm just going to go out between 2 and 3 and make a point there. Same thing on to the left here, between 2 and 3, make a point. I'm going to graph that central box. So that's going to be, let me try that again. That's going to be up here. Something like that. The asymptotes, I'm going to go through the corner here. So that's going to look something, it's off a little bit, it's going to look something like this. And then again, that's off by quite a bit there. Something like that. So we have our asymptotes. And then again, how is the orientation defined? The orientation is defined by which one is positive. In that case, that's our y. And again, I know it's because of that being plus or minus 3 as a y coordinate. So my vertices are here, and we're going to have our hyperbola in vertical in orientation. The foci are at plus or minus 4, which is going to be inside of your hyperbola. So we've got to focus there, above that and below this one. And we have our equation there. Okay, so y squared over 9 minus x squared over 7 equals 1 will look something like this. I'm going to show you really quickly in Desmos. Now this is just always once for horizontal orientation, because I have x squared minus y squared here. But again, it doesn't matter if, so I've got a and b being the same value, so this would be a case where it would be x squared over 9 minus y squared over 9. I would go out 3 in each direction, and that would help me get my asymptotes in that central box. But again, it doesn't matter if A is smaller than B or if A is bigger than B. It's horizontal in orientation because X is our positive value here. Okay, so that's what's determining it, not the number on bottom. And then we've got both of our asymptotes plotted there. And again, notice how the foci are always on the inside of your hyperbola.